For today's math lesson, we are going to do some algebra. Specifically, we're going to talk about exponents and rules associated with exponents. As we get started, let's look at a couple of terms. I'll start with addition. We're all familiar with what addition is. Well, when you add a number repeatedly, what you really get is you get multiplication. And when you multiply repeatedly, what you get is an exponent. So 4 multiplied by itself 4 times is 4 to the power of 4. So what exactly is an exponent? It's a base raised to an exponent where the exponent, in this case 3, tells you how many times the base is a factor in that term. Now some rules associated with exponents. The first one we'll look at is the product rule. When you have similar terms, in this case y to some power, you are going to add their exponents together. So y cubed times y squared would be y to the 3 plus 2 or y to the 5th. And let's look at how this works. Here we'll rewrite that term. And on the left side of the equal sign, we'll just write out what y cubed is. It's y times itself 3 times, and then y squared is y times y. And we can see when we multiply these two together, we end up with 5y's, or y to the 5th. There's an important note on this, is when you're doing this, when you're applying these rules, the bases need to be the same. So on the left side of the equal sign, we've got two different terms that have a y in it and the z. So we will only apply this rule to the y's. So we'd get y to the 4th plus the 3rd, or y to the 7th times z squared. In this case where we have dissimilar terms, we don't apply it. One more thing I'd like to point out is if you see on the left side of the equal sign, I've got dots between the letters. That dot means multiplication. And on the right side, I don't. When you don't have a dot but the terms are right next to each other, it still means multiplication. So I'm just expressing this in different ways so that you can have exposure to all the different ways we would mean multiplication. And as we continue, I'll point out one last difference. Everything that we're going to be dealing with today is dealing with multiplication. However, if we were dealing with addition, different things that account. We are not going to be dealing with it, but I'm just going to point this out to you so that you recognize there would be a difference if we were adding. With the equation on the bottom, you would add like terms, and like term means the base and the exponent have to be the same. So what we would get is we would get 2y to the 4th plus y cubed plus z squared. We're not dealing with that. I just wanted you to be aware that there is a difference. On to the next rule, which is the quotient rule. Like when we multiplied, we use the product rule. When we divide, we'll use the quotient rule, and instead of adding the exponents, we'll subtract them. So y to the 5th divided by y to the 3rd becomes y squared. Let's examine why it works that way. Okay, we'll look at another equation using 2 to the 5th. 2 to the 5th divided by 2 to the 3rd, that equals 2 squared. We could rewrite 2 to the 5th divided by 2 to the 3rd as 2 multiplied by itself 5 times, divided by 2 times itself 3 times, and then we could see that we get 3 of the 2's cancel each other out. Obviously 2 over 2, or any number over itself, is the value of 1. So we end up with 2 times 2, or 2 squared. The next rule is the zero exponent rule. Basically anything raised to the power of 0 is 1. Now, anything except for 0, because 0 to the power of 0 is actually undefined. However, if it were defined, it would be 1, because the limit as the base approaches 0 to the power of 0 is 1. If you put 0 to the 0 power in your calculator, most likely you'll get the answer 1. So in each of these examples here, we've got a term in parentheses, or here we have a fraction in parentheses to the 0 power. It just comes out to be 1. Moving along to the power rule, when we have some base to an exponent all raised to another power, this is where we would multiply these exponents together. Let's look at z to the 5th squared. Z to the 5th squared would be written z to the 5th times z to the 5th, and using the product rule we would add those 5's together and you would get z to the 10th. And that's kind of how that works. And we'll look at it a little bit closer. In this example, x to the 3rd raised to the 4th power is x to the 12th. So let's do this with a real number here. We've got 3 squared raised to the power of 3. We know from this rule that it's going to equal 3 to the 6th, but let's see why. 3 squared can be written as 3 squared times 3 squared times 3 squared. We could further expand that to 3 times 3, and you see that we've got 6 of them there, so 3 to the 6th. Okay, as we expand on the power rule, um, we see that when we have dissimilar terms, we are going to apply the exponent to each of the dissimilar terms in the parentheses. In this example, you would get y to the m times z to the m. And if you had a fraction, the exponent gets applied to the numerator and the denominator. Let's take a look at two examples of this. For the first one, we are going to apply, so we've got 6y cubed squared. We are going to apply that exponent 2 to each of the terms. So we'll get 6 squared times y cubed also squared. And 6 squared is 36. And y cubed squared is going to be y to the 6th. Now let's apply it to a fraction. We'll apply the exponent 4 to the numerator and the denominator. And what we'll get is we'll get y squared raised to the power of 4 divided by z to the power of 4. And that'll result in y to the 8th over z to the 4th. And the final rule we're going to look at is negative exponents. When you have a negative exponent, what you're going to do is you're going to move that term to the other side of the fraction bar and then eliminate the negative sign in front of the exponent. So y to the negative m is going to be 1 over y to the m and vice versa. And here's another example where the x gets moved to the bottom, the y gets moved to the top, and you remove the negative in front of the n. So let's look at perhaps our most difficult looking example today and solve this. So we'd like to express this term without having any negative exponents. So the first thing I'm going to do is I'm going to take the term in parentheses, move that to the denominator, and then remove the negative sign in front of the exponent 2. Now I'll work out what the 2, what the square is. So negative 2 squared is negative 2 times negative 2 or 4. X squared squared becomes x to the 4th. And y to the negative 4th squared becomes y to the negative 8th. And then lastly, what we'll do is we'll move the 8 to the other side of the fraction bar and get rid of the negative sign, and that's done. There's an important note when dealing with negatives and exponents. An exponent only applies to the number that it's directly next to, or everything in parentheses. So in this case, negative 4 is in parentheses, so the exponent applies to the negative 4, and what we'd get is negative 4 times negative 4 equals 16. However, in this term, the 2 is right next to the 4, and that exponent 2 only applies to the 4. That negative in front of the 4 is really like a negative 1 times. It could really be written like this. So what you would get is you would take 4 times 4 is 16, then multiply the negative 1, and you get negative 16. So let's wrap things up. In summary, we talked about the different rules, and we'll just run through them quickly here. With the product rule, when we have similar terms, we'll add their exponents. With the quotient rule, similar terms, we'll subtract the exponents. We talked about the zero exponent rule, where anything raised to the power of 0 is 1. The power rule, where you had a power raised to a power, that's when we multiply the exponents. And then we went on with the expanded power rule, where we distributed the exponent through all the dissimilar terms or to the numerator and denominator if we're dealing with a fraction. And finally, we talked about negative exponents and how we will move the term with a negative exponent to the other side of the fraction bar and then make that exponent be positive. So, and I hope you enjoyed the lesson. If you have any questions, you can run through it again. Thanks.